Okay, going to do a homework with you. 32 problems, a little longer than I'd like, but at the same time, we got to get up and running again because it's a trimester. And so hopefully you can kind of maybe scan the document, decide which problems you want to work on. If there are some you definitely know how to do, maybe it's time to skip those. Otherwise, do them all. It's certainly it's how you're going to learn. It's how you're going to get better is to drill, and talk about the concepts. So the first question is equation of line tangent to tan 2x at pi over 3. So we got a function, tan of 2x at x equals pi over 3. We're going to write the equation of line tangent. So we've got to do f prime pi over 3, x minus pi over 3 plus f of pi over 3. So we got to go to the circle. You see that? Yeah, terrible circle. You're going to do that again. A little better off to the side. So pi over 3 is going to get doubled. So we got 2 pi over 3. 2 pi over 3 is over here. So we got root 3 over 2. We got minus 1/2. And so therefore, that divided by that is minus root 3. So that's going to be this. And so we've still got x minus pi over 3. And now we got to take the derivative, f prime of x, derivative of tan is secant squared times 2. So 2 secant squared 2x. Don't forget to write 2x. Don't just say x. That'll be a mistake. All right, so that brings us to this triangle. And secant is the reciprocal of cosine. So the secant squared is going to be negative 2 squared times 2. Let's see if I got that right. So we're flipping it. Cosine secant, you got negative 2. We're squaring it. Yeah, and so that appears to be 8. And so that is our tangent line. 8 x minus pi over 3 minus root 3. Okay, next problem. Okay. ln of 2x plus 3 g of x equals ln of 2x plus 3. I'm beginning to think you might want to even see these using your log rules. Okay, so when we take the derivative of this, these are constants, they disappear, and we get 1 over x. Okay, but I also want you to learn how to take the derivative of ln with f prime of x over f of x. So maybe we'll do that. G of for x equals 1. So x equals 1. So therefore we need g prime at 1, x minus 1, plus g of 1. So if we put a 1 in, the ln of 2 plus 3, the ln of 2 plus 3. If you want to approximate that plus 3.7, that's fine. Means you know something other people don't know. We got x minus 1, and g prime of x is 2 over 2x. Obviously, 1 over x, and 1 over 1 is 1. So there's your tangent line. And you obviously don't need all these symbols, but that's just the process. Okay, so that's problem 2. Problem 3. And you can replay these and play them. I'm going at a quick pace here. You can pause the videos and look at them over again. So we're going to use implicit differentiation, x cubed y minus 2xy squared equals 8. And we're going to write the equation of line tangent at the coordinate 4, 1. So we're going to get a formula that gives us a rate of change at an x and a y. So we got 3x squared y plus x cubed y prime minus 2y squared minus 4xy y prime equals 0. I'm going to substitute 4 and 1 in immediately. 1648 times 1 is 48 plus 64 times y, 64y prime minus 2, substituting 1 for y, minus 4 times 4, 16 y prime equals 0. So I can find y prime now pretty quickly. So y prime is 48 minus 2, 46. So this is negative 46 on this side. And I got 64 minus 16. So why don't I do that right here? So that's 48 y prime. So what is y prime? Y prime is at 4, 1 is equal to minus 46 over 48 minus 23 over 24. Okay, so now we know we got the line tangent. So let's do the tangent line. Line tangent, minus 23 24ths. X minus 4. We know we got a 1. All right, because that's the coordinate, 4, 1. We just had to find the slope. Okay, so that was that problem. We're going to learn how to do the next problem more easily, a different way, but I will assign that in tomorrow's homework as a video to watch. But right now we'll do this the way that we have been doing it right along. First quadrant area for y equals 8 and x cubed. So we got x cubed, y equals 8, we got x cubed, and we want this area here. All right, so how do we find that area? Top minus bottom. 8 minus x cubed from what to what? Okay, excuse me, I haven't done the integration yet. From, so this is 2 comma 8, that's where it intersects. So from 0 to 2, we're going to do vertical rectangles from 0 to 2. And maybe that's, well, we can do this one out. So that's 8x minus x to the 4 over 4, 0 to 2. So we got that one taken care of. That's nice. So 16 minus 16 over 4, which is 4. So this is 12 units of area. Okay. All right. So moving right along. Drop my eraser. See what the next problem is. These are what your tests are going to look like right along here. Rest of the semester, trimester. 1 to 8, 2x dx. 1 to 8, yep. 2x dx. So we're going to do this geometrically. So there's y equals 2x. Let's just call that 2x, and we're going to go from 1, not drawn to scale. Okay, we got ourselves an altitude of 2, an altitude of 16, and a width of 14. So the trapezoidal rule is 14 divided by 2, interval divided by 2 times the left side of the trapezoid and the right side. So we got 7 times 18, which is 70 and 56, 126, I believe. So that's what we're going to get when we do the fundamental theorem. So let's see if we get 126. So 2x came from what? X squared from 1 to 8. Certainly not going to get the answer I thought I was going to get. 7. So I just got to do this problem all over again. All right. So geometrically, 2x. We got a 1. We got an 8. That's certainly 16. That's certainly 2. 8 minus 1 is 7. That's certainly true as well. Oh, because it was from 1 to 8, and I didn't do the second half because I'm hurrying too much. 2x dx equals x squared from 1 to 8. Excuse me. Okay, so there's 64. Still 63. That's still. Oh, I forgot to 14 divided by 2. Yeah, haste makes waste. So width divided by 2 times 16 plus 2. There we go. So there's your 18. 2 goes into 18. 9 times 7, 63, which does match up now. Okay, so I botched the trapezoidal rule trying to go too fast here. That's okay. That's all right. I said 14. I don't know why I said 14. Tired man here. All right. D of t equals the sine function, which means that s of t, which is, I guess, in physics used as position, so is x of t. You want to become familiar with those notations. So the sine function came from minus cosine t plus c, and acceleration is the derivative of sine, which is cosine t. All right, so we got that done. And S of position, the position, I prefer X of t, the position at pi, is that what I'm looking at, is 3. So what is the cosine at pi? Cosine of pi is -1, but we're taking the opposite of that. And so that's +1, and we got to get to 3. So C is 2. Okay? And yeah, so that's it. All right. So that was solving a differential equation. And we just did 1 to x, 3t dt. Well, you should take the 3 outside the integral. And now we can clearly see that that is 3 times the ln function, ln of t from 1 to x, which is 3 ln of x minus 3 ln of 1. What's the exponent you put on top of e to get 1? That's 0. So your answer is 3 ln of x. And that is our integration. All right. P of x. I wrote F. So used to writing f of x. All right, P of x. Stay there. Equals 4x squared minus 5x plus 6. And we're going to find out when x is 2. Might as well find out P of 2 is 16 minus 10. 16 minus 10, 6 plus 6 is 12. All right, so if I'm going to integrate, I'm going to start from 2 to x. That means when x is 2, I don't care what I write here, I'm going to get 0. But what do I want with it? 2 with 12. So I'll tuck a 12 there. I use some dummy variables here. So why don't we use m? So what's the derivative of 4x squared? Well, I'm going to say 8m. Because when I drop this in, it's going to become a function of x minus 5 dx. That should be another way of writing P of x. And so what we're basically doing is we're looking at from 2, which is probably over here. Yeah, that's a height of 11, right? So from 2, I'm integrating area to the right. We can see that that comes from, some kind of accelerating function. Looking to the left, that means I must be lower. And this is where I change, if this is a derivative, from decreasing to increasing. So I've got some kind of parabola coming from this picture of integrating. And you can see that it is parabolic. Okay, so that's how you do that problem. And I guess if you're going to get these right, you got to think about what I just did. Wouldn't have that there. So that's your answer. Now I'm going to keep asking you how to do that the rest of the term. Be nice if you got it right. How's the function f of x equals 2x cubed plus 4x plus 7 changing at x equals -1. Did I see that properly? Yeah. Well, obviously we need f prime of x, which is 6x squared plus 4. And we got to do f prime of -1, which is 6 plus 4 is. So this function's going up at a rate of 10 to 1 at that instant. So what did this function look like? Y-intercept is 7, going up at 4 to 1. And it's cubic, positive cubic. So bumpity is just going up faster and faster. And in this instance, it's just going in the other direction. So at x equals -1, which is, right around here. Well, I'm a height of 12, though, huh? Let's see, what, -10. So if I have -1, where was I on this curve? I want to do this out a little more carefully. So there's 7, going up at 4 to 1, and then going up faster, yes. And this is written in graphing form. So actually, this was the point of inflection. So -1 gets me, oh yeah, so -1 would have been right about there. -4, -2. So actually positive. One would have been right there. And does it look like I'm going up at 10 to 1? Absolutely. Okay, that was for my own benefit, just because I felt like doing it. Okay, limit as x goes to 2. So we've got the limit as x goes to 2 of 3 to the x minus 9 over x minus 2. Now, you have to see this as a derivative. You have to try to see that we're looking at the function 3 to the x, 2, 3 to the 2 is 9. So this is really your x1 and this is really your y1. And what do we have here? Well, we have a second x, and we have a second y. There's 3x minus 9. There's your y2 minus y1 right there. X minus 2 as x goes to 2. You remember, as x goes to 2, you're really thinking about numbers like 2.01, which is a dx. This is a dy, difference in y's. This is a small difference. That doesn't necessarily mean this is positive or negative or anything else. It's the ratio of change. So what is the derivative of y equals 3 to the x? What is y prime? Y prime is ln of 3 times 3 to the x. So what is y prime at 2? Ln of 3 times 9. 9 ln of 3. 9 ln of 3, which is approximately 9.9. So you're going up at about 10 to 1 for this function as well. What does 3 to the x look like, right? 0 gets you 1, 2 gets you 9. Does it look like you might be going up at 9.9-ish? Absolutely. All right, so that's something you just got to try to see. You just got to keep trying to see it, think about it, trying to see it, think about it, until maybe you get some ownership. Okay, the limit as x goes to 0 of x squared minus 25. Well, I know as x goes to 0, that's pretty much the size of my numerator. When x goes to 0, that's the size of my numerator. X squared minus 25 over x times x minus 5. I'm going to factor that denominator. And now I'm going to factor the numerator. X plus 5, x minus 5. Okay, so we can see the x minus 5's cancel. So I take that back. I should have looked at the whole thing before I started talking about it. All right, so now what do we have? We have a sign change here. When I put 0 in here, that's pretty much going to be near 5. You know, might be 4.9, might be 5.01, but it's pretty close to 5. And we get a sign change with something that's very small, like plus or minus 0.0001. And if you divide that, you're going to either get positive infinity or negative infinity. That's not the same. So this limit does not exist. This limit does not exist. How about the limit as x goes to infinity of 100.67? Close enough. X plus 3. Now, this is really all about your pre-cal experience. So think of 0.67 as 2/3 to the x. Now, I'm going to take 2/3 of 100. There you go. There's 2/3 of it. It's gone. I'm going to take 2/3 of that. It's gone. I'm going to take 2/3 of that. It's gone. 2/3 of that. It's gone. It's gone. What are you headed towards? You're headed towards 3. That was just an exponential decay problem where y equals 3 was the asymptote. And I have some altitude. Then I take 2/3 of it. 2/3 of it. You can see that you're constant. You're very close to 3. That just required some thought and some experience. What intervals is 5 minus x squared? F of x is 5 minus x squared. 5 minus x, the square is on the outside. Well, that's even more helpful. X plus 3 cubed. And we're talking about big F, and we want to know when it's increasing. Big F is increasing when the derivative is bigger than 0, which means you have slopes that are positive. Slopes that are positive, those are all positive slopes. What are they all doing? Pushing your y values up. So we want to graph this sucker. So here's 5. No sign change at 5, sign change at -3. Put a big number in. Squaring is always going to be positive. Big numbers are positive, so that's what your graph looks like. More of a cubic root over here, but I just want to get the answer here. When am I bigger than 0? -3 to 5, union 5 to infinity. That's when you got positive slopes on that curve. Continuing on. Concave up. When is big F concave up? Concave up for big F and F prime. F prime of X is given. Okay, so we're looking at the second derivative. X, 5 minus X, X plus 3 cubed. Yes, we're looking at the same situation here. We want to know when this is greater than 0. That's when grandma's accelerating. Root at 0, sign change at 5. We get sign changes everywhere. So put a big number in. If you put a big number in, that's a negative factor. So this thing is going to negative infinity. Linear change, linear, cubic. That's a little better drawing than the last time. When am I bigger than 0? Negative infinity to -3. 0 to 5. Okay, so that one's done. dy dx equals x cubed minus 4x. Y of 2 when x equals 0. So this passes through the coordinates 0, 2. So what does y equal? X to the 4 over 4 minus 2x squared plus c. We put a 0 in. We can see that c is 2. That's your solution to that differential equation. Solve for f if f of x is 5 and y is 7 when x equals 0. Why would I ask that? Oh, it's a new problem. I thought it was the same, using the same function. Okay, so f of x is 5. That tells me that big F of x is 5x plus c. And we want 0, 7. Basically the same problem, right? So 5x plus 7 solves that equation. Little tougher one. This one some students did the last day of classes before the break. This was one that I gave as a challenge. So f of x equals 5y. And we're after big F again. And the information that we have is 0, 7. After a while, you can just answer these 7e to the 5x. Now, where the heck did I get that? All right, let's go do it. So the best way to do this is to rewrite f of x as, think of it as dy over dx. Okay? And probably I should have written this a little differently as in y prime or dy. I should have probably started there for you. Started right there. I think my notation was a little slippery right now. All right, so you got to get your variables together, and it's easiest if you leave 5 on this side. So y dy equals 5 dx. We're almost done with the calculus part of this. The hard part of this is how much of a foundation did you get in your last class with respect to ln of x? Going to find out. So we integrate here. Oh no, this was division by y. Excuse me. Getting ahead of myself. Okay, so forgive me for that. Multiplication becomes division. All right, so now we're squared away. All right, so we integrate both sides, and if we do, we get. Let me show you what that is. That is the same as 1 over y dy. That's the same as that. So now hopefully you would have set ln of absolute value of y plus c1 equals 5x plus c2. We're going to bring c1 over and make it c3, and we're just going to call that a constant on this side. Okay, so that's it. Calculus is done. And you can ignore this for now. Ignore this for now. Okay. It's just, we want to be able to work with negative numbers. And this is now defined only for positives, but we're working with 0, 7. So we're on the positive side of things, so we can ignore it. All right. So how do you solve for y? Well, y equals e to the 5x plus c. What's another name for y equals e to the 5x plus c? Y equals e to the 5x times e to the c. Okay, there's your rules of exponents. I see I got a little glare on the, well, okay, I'll move that up top. All right, so I'll do that again. E to the 5x plus c is equal to e to the 5x times e to the c. Starting to run out of marker here. All right, so what's another name for e to the c? Well, that's just a constant. That's just an amount. E to some constant, we'll call it amount A. Okay, so I now know that y is equal to a e to the 5x. I know that 0 gets me 7. When I plug a 0 in, I get e to the 0, which is 1. So therefore, a has to be 7. Y equals 7 e to the 5x. Now, it's probably useful to take this derivative just to show you where it goes. So this is y prime is equal to 5 times 7 e to the 5x. And that's the same thing as saying dy dx equals 5 times, where have I seen that? Oh yeah, that's y. And that's the initial question that I asked you. Okay, so it comes right back to that. Feel free to play that again a couple of times. Could be on every test the rest of the way. Y equals e to the minus x over 2x. Hopefully you remember the jingle for y prime. Some of you got it wrong on the last test. I got news for you. You can't afford to get a problem like this wrong. Low, d high. We all make mistakes. D high is, so low, d high. Don't forget the minus, the chain rule. So put it in parentheses, minus e to the minus x. There's low d high, minus high, d low. I mean, I'm going to start putting the chain rule so that it looks a little more readable. Over low, low. Put the thing in parentheses and square it. And don't make a mistake and say 2x squared. So low, d high, minus high, d low, over low, low. Yep. So left-hand rectangles. Square root of x from 4 to 9. All right, 4 to 9, 5 divided by 3 is the width. So I'll write 4 as 20 over 3. Where am I at now? 4 divided by 12 over 3 is 4. 9 is 27 over 3. There we go. Got the brain working now. And so that allows us to write these two values more easily. So that's 17 over 3. That's 22 over 3. Yep, so now we're good. All right, left-hand rectangle, square root of x. So we got 5/3 is the width. First altitude is the square root of 4. I'm just going to write 2. Next one is root 17 over 3. Next one is root 22 over 3. And the last one is square root of 9, which is 3. Okay, so there's your, I only wanted 3, huh? I just did I wanted left hand, so I don't need this last one. Okay, so it's 3 left hand, so that one, and that one. Okay, 2, boom, 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 boom. Good now. All good now. Shouldn't have erased it. Do I want trapezoid? Yeah, figures I did trapezoids. All right, so it was 5/3, so now it's 5/6. I got to cut that width in half. I still got a 2. Now I got to double the interior ones. I got to double the interior ones. And I do have to write the last one. Square root of 9 is 3. Okay, so there's the traps. At this stage, you should not be making mistakes on them. Everybody makes mistakes, careless mistakes, but you should 9 out of 10 times at least get your left hand, right hand, and trapezoidal problems correct. 5 billion right-hand rectangles, or as close as you can get. Well, as close as I can get, I'll get exact. I'll integrate the square root of x from 4 to 9. So that's x to the 1/2. We've done this a lot. So that's 2/3 x to the 3/2 from 4 to 9. So that's going to be 3, 27, 9, 18. Oh God, we've done this one so many times. I think 2, 8, 16/3. 4 square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16/3. 8 is 54/3. 44, 38/3. That's pretty much that exact area under the curve from 4 to 9. All right. I hope this marker holds up. Getting there. Maximum value for y equals minus 4x squared plus 8x minus 5. So we got ourselves y prime, which is minus 8x plus 8. So we now know that at x equals 1, we get this sucker to turn. We know it's concave down, but we got to prove it. So we'll prove it with y double prime, which is minus 8. So y double prime of 1 is minus 8. So therefore, I'm on a concave down interval with a slope of 0, and I'm trying to find the maximum value. So I'm going to plug 1 into this function. Minus 4 plus 8 minus 5 is 4 minus 5, negative 1. So I wrote negative 1 up there. I should have written positive 1. So negative 1 is the maximum value. Please do not write it as a coordinate. Maximum value, negative 1. Justification, concave down interval, slope of 0. All right, trying to get this so that I can upload it soon. Find the average value, y was 2x, 0 to 6. So what we're trying to find is that place where, and we know it's symmetric, right? Where this area is offset by this area. And that is our average value, which is going to be 2 times 3, which is 6. How do we find it with integration? We'll take the area under the curve, 0 to 6, 2x dx, and we divide it by 6 minus 0. Okay? So 2x came from x squared from 0 to 6. Dividing by 6 gets us 36 over 6, which we said was 6, which matches up with the picture we had a moment ago. So that's the average value of that function from 0 to 6. We know it's 0 here, right? We know it's 12 here. So yeah, that's the average value, 6 units high. Formula gets it, right? It's average value formula. Area divided by width gets us height. That's what you're looking at. Area under a curve divided by the width of the curve in question. That's just the average height of that curve. All right. Average rate of change. X to the 4th minus 2x. We're going to go from 0 to 4. A lot of you got this wrong on the last test. I got news for you. You want to pass this course, don't get it wrong again. This is Algebra 1. Okay, average rate of change. 0, 0. 4 to the 4. What is it? 64, 256 minus 8. 256 minus 8. 248, I believe. Okay, doing some mental math here. So we got 248 minus 0 over 4 minus 0. So we're finding the average rate of change. Slope of the secant line. This function probably looks like this, concave down, probably looks like that, and we're going to go from 0 to someplace up here. We're going to look at that slope, and it looks like 62. So it's going up at 62 to 1. Okay. Hopefully I didn't butcher that. I am getting a little tired here. And we want to know when that is equal to the derivative. You know, at what interval? What interval? It looks like it might be. It looks like it might be down here somewhere. I'm not sure. Let's find out. Let's find out. So we're looking at x to the 4th minus 2x. So we need y prime. So y prime is 4x cubed minus 2. So I'm going to add 2. So that's 64 equals 4x cubed. 16 equals x cubed. See, I think that's right. So the cube root of 16. Cube root of 16, a little bit bigger than 2 units. So yeah, it makes sense. A little bit bigger than 2 units. Right, but it would be further up here. There's 16 minus 4, somewhere in this vicinity if I drew it better. All right, so that's 32 problems. I don't know how long that took me, but you try to get some practice in. If you want to just work for an hour, it's fine. It's all I'm supposed to assign you. But some of you are way behind based on what I saw on that first take-home test. Some of you are so far behind you didn't even bother to send it to me. Now, that's a white beard, not wearing a red hat. So for those of you who didn't send anything in, let's get off to a little better start in 2021. Be good for you to work. Everybody says it's good for mental health to get into some kind of schedule. So if any of you are struggling, and who isn't these days, right? We all got to get through this. Let's listen to the professionals. Let's get a little schedule. Mark your calendar. From this time to this time, I'm going to do some math. All right. Night-o.